Okay, we begin with the introduction to the organic chemistry, but before that, you all are familiar with the subject chemistry. Um, if we need to uh, define chemistry, uh, we define as the branch of science in which we study about matter. Matter means anything that has mass and that occupy the space. And chemistry is a very vast course. So in order to make it convenient in study, the scientists have divided chemistry into various branches. And one way of classifying the chemistry is to classify into three main branches. One we call organic chemistry, second one we call inorganic chemistry, and third one is biochemistry. Biochemistry. And organic chemistry we can define as the branch of chemistry in which we study about the carbon compound. In one sentence, organic chemistry can be defined as the branch of chemistry in which we study about the carbon containing compounds, whereas inorganic chemistry is uh, is the branch of chemistry in which we study about the elements other than carbon and also include the carbon containing compounds like bicarbonate, carbonate, etc. we study in inorganic chemistry, whereas the biochemistry is the branch in which we study about the chemistry related to biological processes. Okay, here is a biological processes. Inorganic, uh, the chemistry of all other non-carbon compounds and also some carbonate and bicarbonates, and organic chemistry is the carbon containing compounds. That is what we study in organic chemistry. Now the question comes is, so if we put all organic chemistry in one side and all other branches of chemistry in one side, the organic chemistry is still a very vast course. The question comes is why the organic chemistry, the chemistry of one element carbon, is such a vast course. So in order to understand that, we need to be familiar with some of the features of carbon, some of the special characteristics of the carbon. So one characteristic is its position in periodic table. Okay, we are trying to discuss why the organic chemistry of the or the chemistry of carbon is such a vast course, right? So first is about the position of carbon in periodic table. So if you look at the second row in a periodic table, there are the elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And the carbon, if you look at its position in the periodic table, it belongs to second period and group 4A in the periodic table. So because of this group, it has 4 valence electron, right? So because of this 4 valence, and you know that the elements that is on the left side of this in the period, they have fewer number of electron, so they will try to lose these electrons. So whenever they lost the electrons, they will form the positive ion or cation, right? So on the right side, we have the elements that has what larger number of electrons, so they will try to gain electrons, one or more electrons. So whenever they gain the electrons, they will form the negative ion, or we also call anion. Now because the carbon has 4 electrons, it will neither try to lose the electron nor it will try to gain the electrons. Rather than that, it will what share the electrons, share electrons. So whenever it will share the electrons in order to complete the octet, uh, it will share 4 pairs of electrons. That is why carbon always forms what 4 covalent bond by sharing 4 pairs of electrons. And in these 4 bonds, what happens is this 4 bond can be by sharing the electrons. That means so it's 4 covalent bond. It can be all 4 single bond, or it can make 1 double and 2 single bond, or it can make 1 triple and 1 single bond, or it can make 2 double bond. Please take a note on that. In each case, carbon forms what? 4 covalent bond. It can form all 4 single bond, 1 double and 2 single, a triple and a single, or 2 double bonds. Okay, this is one very important feature. So because of these various possibilities, carbon can form millions of compounds, the carbon containing compounds. That is why that is the one uniqueness. The other unique feature is whenever the carbon forms the 4 covalent bond, or forms 4 covalent bond, it can bond with other carbon atom, forming a long chain like this: 1 2 3 4 1 2 3 4 1 2 3 4, like this, for long chain. Or it can form the branch structure like that, or even they can also sometimes form the ring structure. They can form the ring structure like this: 3-member, 4-member, 5-member, 6-member ring. So this property of carbon is called catenation. And because of this catenation property, carbon can form varieties of structure, or varieties of large number of compounds. And by now, more than 20 million organic compound has been discovered, and this number is growing day by day. And whenever this carbon forms the uh, covalent bond, it will form with a bunch of elements that share the electrons and forms the bonding with carbon. So the best friend with the carbon here is one is hydrogen, and other is nitrogen, oxygen, and sometimes halogen. Halogen is X. That means it can be chlorine, bromine, iodine, and sometimes, rarely, fluorine also will involve halogens. And sometimes you will see along with carbon there will be the sulfur and phosphorus. These are handful of elements that involve in forming the covalent bonding. These are the unique feature of carbon that makes the organic chemistry such a vast branch of chemistry, and is a very big branch of chemistry as well. All right. Now, so in order to understand the organic chemistry, so we need to know, or we need to know very detail about the carbon. So carbon is also the element. Therefore, first of all, to understand about the carbon, we need to know how the bonding takes place, what are the possible types of bonding. So these are the things that we need to understand. So before we go further than that, we need to revisit our general chemistry, and you understand a little bit about the element carbon and its electronic configuration, and so on and so forth. Okay. So you all are aware that the atoms are made up of 3 fundamental particles: proton, which are positively charged particles; electrons, which are negatively charged particles; and neutrons, these are no charged particles. Right? These are the 3 main subatomic particles from which the atoms are composed of. And proton and neutron all are located in the central core, that is what we call nucleus. Again, I'm trying to quickly review your general chemistry materials that you have studied in your Gen Chem 1, Gen Chem 2, right? And electrons are revolving around the nucleus, okay? Revolving around the nucleus. And the other point is the number of proton present in the nucleus. That is one of the unique feature of each and every element. This number of proton, we call it what? Atomic number. Atomic number is the number of proton. And see, as such, the isolated atom is electrically neutral. What does that mean? Electrically neutral. That means what? It is a number of proton is equal to number of electron, because the protons are positive charge, electrons are negative charge. Since their numbers are equal, they cancel each other and then gives the neutral. So atom is electrically neutral. Okay, and the proton has got the mass of 1 atomic mass unit, AMU. Neutron also has 1 atomic mass unit, and electron has mass very negligible, like 0.0000054 atomic mass unit. So we almost neglect the mass of the electron. So the proton and neutron, these are the component of the nucleus that will decide the mass of the atom, and that is why we call that as the mass number. Mass number is the sum of number of proton and neutron present in the nucleus. Okay, these are again the material that you have learned in your 1045 1045 or 1046 or GenChem 1 and GenChem 2 courses. Okay, so that is the mass number. And sometimes there is another term you need to be familiar with, which is also called isotopes. The atoms of same element contain same number of proton, or atomic number will be exactly the same. That is what we call the identity of the element. But however, the atoms of same element may contain different may have different mass number, and this is because of due to different number of neutron present in their nucleus. That is what we call isotopes. All right, say for example carbon. Let's talk about carbon. It has, some book mention about 4 isotopes of carbon, some book mention about 3 isotopes of carbon. So let's say 3 isotopes of carbon. Carbon has 3 isotopes. One we call carbon 12, other one is called carbon 13, and one is called carbon 14. Carbon 12 means this number of proton in each carbon is, of course, it is 6. That is the atomic number, that is number 6. Of course, then number of electron also will be 6 electrons in each. Now, in carbon 12, number of neutron, that will be 6. So that 6 and 6 is 12 mass number. And carbon 13, number of neutron is 7. So 7 and 6 is 13. And in carbon 14, number of neutron is 8. So these are the 3 isotopes of carbon. Our common carbon that we discuss frequently is carbon 12. That is the most common carbon. Carbon 13 is nearly about 98% of carbon is carbon. Greater, more than 98% is carbon 12. Nearly 1% is carbon 13, and very small amount is carbon 14. So these are the isotopes of carbon. All right, so this is about the isotopes of carbon. Now the next part that we need to be very familiar here is, say other common element is also called hydrogen. Right, there are hydrogen, symbol is H. There are also 3 isotopes of hydrogen, like hydrogen 1, hydrogen 2, and hydrogen 3. These are 3 isotopes of hydrogen. In this one, say here number of proton in each case is what? 1. Of course, number of electron is also 1, whereas number of neutron here in regular hydrogen there is no neutron, whereas in hydrogen 2 there is a 1 neutron, which is also sometimes we call deuterium, and H3 there is 2 neutron, and we sometimes also call that as tritium, right? And H2 is also sometimes people call that as deuterium. These are 3 isotopes of hydrogen. So you need to be familiar with the isotopes of carbon and isotopes of